vSphere fault tolerance is a really amazing feature of an HA cluster where we can guarantee 100% uptime in a virtual machine by mirroring that virtual machine on a secondary ESXi host. It's really neat. Let's see how it works. We'll look at, first of all, the benefits of vSphere fault tolerance, which should be relatively obvious, especially when it comes to virtual machines that don't have any native clustering features within the applications. We'll look at the architecture of vSphere fault tolerance, and then we'll look at a little bit how it works with HA and DRS and that interaction, okay? Then we'll simply look at how we enable fault tolerance on a particular virtual machine. Here's what we do. ESXi host 1, ESXi host 2, virtual machine, enable fault tolerance. Another virtual machine is fired up on the secondary ESXi host, and a copy of its files are created on another data store if you've got another data store available, but at the very least, you create a second copy of those virtual machine files. Now, virtual machine A is up and running, and in order for that to support the failure of that host, and for that VM to instantaneously be running on the other host, we have to copy the state of this virtual machine in near real time to the secondary ESXi host so that we can have zero downtime, zero data loss, and no loss of virtual machine network connectivity. Let's see actually how this is done and what some of the limitations are for this. In vSphere 7, we support virtual machines with up to 8 virtual CPUs and 128 gigs of RAM. Now, on each ESXi host, we can support up to 4 fault-tolerant VMs with no more than 8 vCPUs between them. So that could be a single VM with 8 vCPUs, or 2 VMs with 4 vCPUs, or 4 VMs with 2 vCPUs. You get the idea here. Now, vMotion is supported for these VMs. We can vMotion both the primary and the secondary virtual machines. Okay? We are creating a secondary copy of all the virtual machine files and the VMDK files, right? And we provide a fast checkpointing mechanism that I'll describe in a second to make sure that the 2 virtual machines are kept in lockstep with one another. In terms of the virtual machine files themselves and the VMDKs, we support thin provision disks and thick lazy zero disks as well. We call this out because in previous versions of fault tolerance, we only supported thick eager zero disks with actually 1 vCPU in the VMs. So since the release of vSphere 6, we've really made a lot of improvements to vSphere fault tolerance. Now, if you want to use this in a DRS cluster, you've got to have enhanced vMotion compatibility enabled. Even if all the hosts are homogeneous, make sure that you just set the baseline at whatever is set up for all of the hosts. We also support vSAN, so hosts that are in vSAN clusters are also supported for this. Here's the idea, right? Now, I have to have vSphere HA turned on, and vSphere HA will restart a failed primary VM on another host after the secondary VM has taken over as the primary. DRS will choose which hosts to run the primary and secondary virtual machines on, but will not automatically migrate fault-tolerant VMs. Okay? It'll essentially create an individual VM override for those VMs for automation that says disabled. Primary machine fires up, okay, on one host. Secondary virtual machine fires up on a second host. Upon the failure of the primary host, the secondary VM becomes the primary, and a new secondary virtual machine is created on another host. Okay, that's what HA is going. That's what vSphere fault tolerance is going to do for us. Now let's dive a little bit deeper into what's going on during a failure. When you create virtual machines, and we're creating a secondary VM here, and we create a secondary copy of the virtual machine files, all of those files are separate from one another. Now I want you to consider the VMX file, because the VMX file itself contains the unique identifier of each the primary and the secondary VM. Okay? We're also going to have separate VMDK files, and they should be on separate data stores. Okay, so keep that in mind. Then, when we have new writes to memory in the primary VM, those writes to memory are copied over what we call a fault-tolerant network, over to the secondary ESXi host. We've seen mechanisms that copy memory from one host to another. It's called vMotion, you remember, right? So what this does is it utilizes the idea of vMotion, copying changes of memory from one host to another host, but rather than switching to the secondary host, we never do that until there's a failure. We just continue to copy changes from the primary to the secondary host. Okay? Memory will be updated. If there's a failure on the first host, the secondary host will be ready to run the VM in the exact same state. We'll start by executing a pre-copy. That is, we take the entire virtual machine's memory footprint and copy it over to the secondary ESXi host. Then, when there are changes done, we copy those changes. Okay? So we start with this memory pre-copy. Now, this occurs not over the vMotion network, but over a new set of VM kernel ports that we create with the fault tolerance logging checkbox created on that VM kernel ports. Okay? So it really is a separate set of VM kernel ports that we create here. So then, when memory changes and things like that, we execute this fast checkpointing, copying the memory from one host to another. Okay? Now, we institute a quorum mechanism so that the secondary host is not able to take over the role of the primary in the event that the primary is still created or still up and running. So this is what we do. We have two files, and these two files have to be on a data store that is common between two hosts. We have the shared VMFT, and we have the .ft generation file. The shared VMFT contains the unique identifier of the primary VM, okay? Because we know that the VMX files that contain the unique identifier of each VM will be different. But when we do a failover, we want the secondary VM to take over the identifier of the primary. So when there's a failover, the secondary VM reads the unique identifier from the shared VMFT file and writes it into its VMX file so that it is now considered to be the primary VM. You can then see that the secondary VM takes that EUID. It's now the primary VM. Here's the next thing that happens. During normal operating circumstances, what happens is the primary VM creates a lock on the .ft generation file. Okay. The secondary host attempts to rename .ft generation to .ft generation 2. Of course, when the primary VM has a lock on that file, it's not able to rename it until the primary host fails, at which point the secondary host says, ooh, I just renamed that file, I better become the new primary VM. And that's how that failover to the secondary host actually occurs. Enabling vSphere fault tolerance in an HA-enabled cluster is really easy. Find the virtual machine that has 8 or fewer vCPUs, right-click on it, Go to the fault tolerance menu and turn it on. It'll ask you to choose a new data store for the secondary copy of the virtual machine files, and it'll prompt you to either allow DRS to choose the new location for the secondary VM, or you can choose it manually. Okay? You also have the option of turning off fault tolerance, suspending and resuming fault tolerance, and migrating this secondary virtual machine with vMotion. So that does it for fault tolerance. It's a really great feature, but it does consume some resources. You know, we're copying memory over. It's like a vMotion that never ends, really. So you want to use this sparingly, really only in cases where you require 100% uptime in the application, and the application itself doesn't include any other clustering sort of features. If you are in that case, then fault tolerance might be a great feature for you, okay? So we understand fault tolerance, we know how it works, we know how it interoperates with HA and DRS, and we know how to turn it on very simply with a right click. Let's look at this activity that they've set up for us where we're going to match the goal, what are we trying to accomplish, with the feature that might accomplish this. So take a minute or two and have a look at this. And the next slide will give you the answers. We've gone now through an entire module of cluster features and cluster configuration. And we looked at DRS and we looked at HA. And I also promised you that I would show you a demonstration of cluster quick start, which I actually took from my home lab. And I hope you enjoy it. So that should be the next video available and you can watch that. When we come back in module 10, we're going to look at how we maintain the software on our ESXi hosts with Lifecycle Manager. We'll talk to you real soon. See ya.